that adversary. What is he after? Or say that, are there any hosts which are also equally compromised? So you can do whole bunch of things, and this is completely different, because if you look at then the current security data science, that is mostly boiling the ocean and then finding the anomalies, and the security analysts are sort of in the alerts deluge, and they are having a tough time. In our case, we want to be friends. We want to be friends with the security analysts, and we want to say that we're going to reduce the number of alerts for you, and we're going to say that if you got this alert, what to look for, and what are the characteristics or the profile of the adversary. So here is one such example where I'm going to go deeper and just give you a flavor of it, and this is adversary traversal analysis. Now, as I was telling you, right, you collect whole bunch of data, right? That data is actually being stored in a data lake, and in the security industry, that data lake is called SIM, Security Information and Event Management Tool, and Splunk is one of them, and they are our partner. Now, we take the security events data from Splunk, and we have our deception data. We correlate that, and we figure out that what's the path which adversary may have taken, and that's what we are calling it as adversary graph analytics. Now, here also we have a theme that we should not boil the ocean. So how that theme works out is, first of all, you are starting from a deception. A deception sensor got tripped, and you know that, okay, the person or the malware who got tripped onto that sensor is very much with a bad intent. It's likely to be adversary, and you take that data, you figure out from which host he got bumped onto, and then you start constructing your graph. You start doing in the back in the time. You take the data from the data lake, you construct your graph, and then you construct something like a signal to noise ratio, some kind of a framework. And that framework has to compute signal. And the signal has to be all about adversary's presence, what all he has done. And the noise is obviously there are a whole bunch of events happening on that host and related with the other users as well. And so this SNR framework is going to ensure that the graph trajectory has to really move in the way where the adversary may have come. And you construct one layer, and then you give it back to the graph, and then you do it in an incremental fashion, and that will make the adversary graph. Now, this is a picture of that adversary graph. What you see here is, this is the, I'm going to start from the right side here. This is the host from where adversary got bumped onto the deception, and this shows the IP addresses here. And this could be anything from low interaction to high interaction, anything it could be there. So he got bumped over there, and we construct the signal, and we say that, okay, adversary may have come from these hosts. What are the different paths he may have come from? And we are going back into the time. And then once we come here, then we again pull the data from SIM, and then again compute SNR and figure out, okay, what are the different hosts he may have come from? And then we again construct. And once we have, we go back into the some time, and then we say that, okay, now we don't have enough signal anymore, and my SNR has dropped down significantly. So we need to figure out, okay, what's the most likely path adversary may have taken. So we construct that most likely path, and we say that, hey, this is the path the adversary may have taken. Now think about it. Isn't it amazing? Why it is amazing? If you, a security analyst, have to make this kind of a graph, incident response guy has to make this kind of a graph, I can bet it will take days or it would take weeks to do it. It's very, very hard because you have to correlate, you have to figure out all that signal and the noise. Obviously, I'm not saying the data science alone has to do it. It has to be a combination of a domain and the data science together. And that's a blending has to happen for this graph have to be perfect. And it's not going to be perfect, it will be probabilistic. It's never going to be perfect, it's really probabilistic. But the security analyst would be starting from this graph. He would say that instead of looking at the 10,000 machines in that particular subnet or around in that enterprise, he can focus his investigation on the hosts or the network devices that popped up in the graph. And then he starts his investigation from there. So this is, we are calling it as adversary graph analytics, and this is one such example. So in a nutshell, what I talked about is security attacks are increasing day by day. And as we know, right, there are a whole bunch of IoT talks, and I think, I forgot you, I think you were there in one of the security panelists as well, right? Sorry, and one of the panelists as well talking about the IoT, or maybe not you or somebody else. But I think it is, the IoT is going to be again one more addition to it, which will be giving a lot more surface for attack. So a lot more devices you add is good for the hackers. They're going to hack it. There have been so many hacks being shown where attackers can get into the nuclear plants from the gas stove. They start their hack from the gas stove and they go incremental fashion up to the nuclear plant. And there have been hacks which are shown. So security attacks are coming on our way, not just the enterprises. They are coming to us. They are coming to our houses. They are coming to our cars and to end user, just a further downstream. And are we ready for it? Probably not, and not really, as the number of data breaches being shown. We need a new thinking, a new shift in the security defense. And deception and the security data science combination is going to do that. It's one of the approach. Obviously, there are multiple solutions and multiple approaches being coming in the market. And this is one of the approach where defense team is, security defense team is coming up. And we are playing a one role over there. Now, there is a message for data scientists. And the message I'm going to say that this field is open for fundamental breakthroughs. We have seen the recommendation system, we have seen anomaly detection, many of things, but is open for innovation. And when we combine the events, do a correlation from there, and how do you go back and construct the context and do a whole bunch of use cases around it. So this is sort of an event-triggered data science, and I think we have just scratched the surface. So we are very excited about this particular journey, and I think I'm good. And let's have the questions, please. Sure. So I'm sorry, I missed your half of the question, and I get second half. Honeypots, okay.
Honeypots have been around for a long time.
Sure.
Hackers are very brilliant.
Sure.
Black and gray hackers, right? Know this. There have been a I mean, this concept has come up, I think, in the last 2 years,
Sure.
and they have evolved. So how would this be effective, and how do we make sure that we are actually ahead of them?
Right. Okay.
It's a bit of an unfair question.
Yeah.
But it's just nice to ask.
Yeah, sure,
Thanks.
sure. Yeah, good. So it's a good question. So honeypots being there in the industry from long, okay. But have they been made in a scalable fashion? Or, are they able to deceive? If you look at, the honeypots, any kind of honeypots from low to the high, there are blogs being written. There are, all the information on the internet. How do you detect those honeypots? Because those who build it, they also revealed it that, hey, somebody hacked it and then say that this is how I'm going to hack it. Now, if you need to build a deception, and obviously we are deception 2.0, what that means is like you need to make it in a believable fashion and also which can deceive as well. So there are a couple of aspects. Number one is it should be able to deceive. In that case, I'll just give a very simple example. If you look at some of the existing honeypots, they have a fixed host name. Now, if you just look for the host name, you will immediately know that, hey, this is a deception. This is a honeypot. And now, can you use the interesting ways to give a deception on the host name, and so that it deceives? Now, give you the another aspect of it. It needs to be scalable. Now, can you put thousands or hundreds of deception points, and in a way which is enterprise can handle it? Because in an enterprise, if you have the real users near and also the deception over there, how do you play out the deception? And also at some point, you want to make it in a way that IT admins can actually execute that, and they could turn off, turn on in a way they want it. So, and also another thing is, it should not really become another point for a security attack. So if the attackers actually start their attack from the deception, that would be very bad, right? So how do you really do it and ensure that if you're playing out a deception at enterprise level, which can do a deception at thousands of points, and also believable fashion and maintainable, then you need to have innovative thinking over there. And then the second point is, how do you get the insights around it? And that's where the focus of this talk was, the deception triggered data science. I'll just take this question.
I have a multi-part question. So one is, can deception scale? Because hackers are also going to come up with deep learning algorithms to get into the system, right? Because a lot of people make their livelihood just doing that. So can deception really scale, particularly when you have so many other techniques that can overcome this particular stuff? The other thing is, from what I understand, security is predominantly a very reactive field, right? So, I mean, the way it's done, oh, some breach has happened, so let's go and fix it, right? So that's what you told, that security analyst gets 300 cases a day. And how do you even envision that becoming proactive rather than reactive?
Sure. So yeah, good questions. So the number one is scalable. Obviously, we have shown it over there. At least not only us, there are multiple companies in this space, and they are showing it to the enterprises that deception is scalable, and they have, some of them are actually being sold, and people are trying out. So this particular space is very, very energetic, and it is coming up fast. And what you need to really use is more a creative way of software-defined networking, SDN, and do a whole bunch of things around there to really make it believable and also maintainable. That's the number one. And number two is, how do you handle with the alerts deluge problem? What we are saying is, we're not going to do mining of each and every user or the network all the time. What we are saying is, we're going to put the deception around in a smart fashion, in a maintainable fashion. And if somebody is going to bump onto that, and it's not going to be static, it will be changing. it will be changing. And now if somebody bumps onto it, then we will start the data science. We'll look around, okay, who did it, who set the alarm up, and then construct the story around it. Okay, so we'll take it more offline. Thank you. Thank you very much.
All right, thank you, Satnam. Ladies and gentlemen, moving ahead, before I call in the next speaker, a quick announcement for the hackathon that's happening, the final selects for the hackathon. The hackathon is going to start sharp by 5:30 p.m. towards the boardroom area. That's just onto the left side of this particular hall. Yeah? If you are a part of the same hackathon, request you to please report there by 5:30 p.m. And there was one more announcement. A few of them had actually not carried these tags this morning, and it's a kind request. Do not forget these tags for tomorrow if you're joining us, because this is very important for you to get it. Ladies and gentlemen, moving forward, up next, the topic is improving B2B sales efficiency using machine learning or AI, that's artificial intelligence, plus human in the loop. And to talk on this, we have a person who is a senior data scientist at Cisco Systems, India. He has 12 years of experience delivering business analytics or data science solutions to investment banks, entertainment studios, and high-tech companies. His interest lies in enabling the business to make better decisions using data. He has given talks and conducted workshops on data science, machine learning, deep learning, and optimization in Python and R, both in India and abroad. He has a master's in statistics from University of Maryland, College Park, USA. He's an ardent NBA fan. Ladies and gentlemen, it's the senior data scientist at Cisco Systems. Please put your hands together for Bhargava Subramanian.
Good evening, guys.